All right, how's it going, folks? There's been some questions about if there are more than just the 3 kinematic equations that we've been practicing and memorizing this whole unit. And my goal in this video would be to show you that there are not. There are only those 3 kinematic equations. But we get to use them once in the x direction. We get to use them once in the y direction. Because we use them in the y direction and the x direction, sometimes the answer key has put like different names on some of those letters. So I want to show you that they're all the same set of 3 equations. So if I've got something that was shot at 25 degrees above the horizontal, let's say with 19 meters per second of initial velocity. That could be written as VI, or that could be written as V0, same meaning. Similarly, I could write the x component as VIX or as VOX. Okay. If they were to ask me about the total amount of time it spends in the air, one way that I could do that question would be to identify that at my highest point, I've got symmetry on the left and the right. So VFY is equal to 0. So I'm going to make an equation that's all y information. So all my y information is that AY equals negative 9.8 meters per second squared. VFY equals 0. The initial y equals 19 sine 25 degrees. And if I'm solving for time, then I want an equation that has these 3 and time. So that's going to be VF equals VI plus AT. 0 equals 19 sine 25 minus 9.8t. So you might have seen an equation that said something like t to the top equals v initial y over g. It's not a new equation. That's just rearranging VF equals VI plus AT in the special circumstance where VF, aka the top, is 0. Okay, so we could do that and we would get our time for the top. I don't have my calculator on me, so I'm just going to write smiley face. Separately, now imagine instead of solving for time, what if my goal would be distance? Oh, I'm sorry, one more thing. For the time to the top, if they ask me for the total time spent in the air, I would just multiply this whole thing by 2. And so my final answer for the top would be multiplied by 2 in order to get the final time, the total time it spends in the air. Next, if I was given the same 3 pieces of information, but they asked me for the height at the center, the highest point it reaches, well, the highest point still happens at VF equals 0. But now there's a different equation that's relevant. That to me looks like VF squared equals VI squared plus 2AD. And I want to clarify that everything I'm thinking about is in the y direction. VFY, V initial y, dy, AY. Now specifically, dy is h. That's the height that I've gotten to. And AY is gravity. That's the 9.8, negative 9.8. So you might have seen equations that say 0 equals V initial y squared minus 2gh. But it's ultimately the same equation as VF squared equals VI squared plus 2AD. Or you might see it rearranged as V 0y squared over 2g equals h, but it's all the same equation. I can't go through every single equation that might exist, but there's going to be one more that I'll show you guys. But my main takeaway is that there's only those three equations. Don't worry about memorizing these special case equations. That's not worth your time. But imagine it says the total range of the launch. Well, when they refer to range, they're talking about the total x distance. So I'll say dx equals v initial x times t plus 1/2 axt squared. And you say, Mr. Berger, there is no ax. Ax is always 0 in a problem like this. So that makes life good for me because ax removes that whole term. And all I'm left with is dx equals v initial x times t. But in the answer key, sometimes they use r, range, to mean dx. R equals v initial x times t. Okay. That's the bell, so I gotta go. But I hope that helped.